Okay, so this is response 5 to the responses videos between myself and I Can Science That. So let's get started.
Good evening. This is going to be a response part 4 of this sequence of responses. Now, for this one, I want to just drill into this hypothesis of relative density. I want to make sure I absolutely, completely understand what you're saying because, just to explain, from my point of view, I was taking relative density to mean something quite different from what you are saying. I've been saying all along that there's an external vector that gives us the direction that things move, and I've been showing how that's related to acceleration. You, on the other hand, are saying that it is the density gradient that is the cause of how things move. So I know you've answered this. I want you to be very, very clear with me right now. So I'm going to go through very carefully what I understand from your hypothesis, and I want you to correct me about anything that I misunderstand. Let's be absolutely clear so that we're totally on the same page. And then after this, we will design experiments and test the hypothesis. So please lay out for me exactly, is this correct? I want to try to be as precise as possible so that I do not misunderstand you. Again, the idea here is that if you can be completely clear with this, we should be able to create experiments to test this as a formal hypothesis. So here we go. To begin with, any object moves toward the location within the medium that matches its density. So to clarify, dense objects move toward wherever the medium is denser, and the less dense objects move toward the location within the medium that is less dense. So objects will come to rest where their density matches that of the medium they're in. Again, we are.
Okay, so dense objects move towards where the medium is denser. Yep. And then less dense objects move towards where the medium is less dense. Yes. Okay. However, that sounds like you're just making it about the gradient. I'd like to say that I don't think it's just about the gradient. So if there's a gradient, then yes. If there's a gradient, dense objects will move towards where the medium is denser, less dense objects will move towards where the medium is less dense. Objects will come to rest where their density matches that of the medium. If it can, yes. So if it can get to its own density, then it will, and that's where it'll stay in equilibrium. If there's not a gradient, I'm not even sure whether you can get something without a density variation in, but let's say we had a medium that had the same density. I'm not sure if that's possible, but let's just say we did. I still think less dense would rise and more dense would go down, because relative density is the difference between the object and the object's density and the medium's density. So to me, that's how we've got the gradient to begin with. So basically, in nature, the reason that more density is down and less density is up is because you've got a medium, and less dense is up and more dense is down. So that's kind of where the gradient come from to begin with. So if you imagine just everything, just imagine one medium, and then you had all objects of different densities, or all gases in this medium of different densities, and then just imagine it sorted itself out so that more dense was down and less dense is up, because more dense in the medium down, less dense in the medium up. You'd end up with a gradient eventually anyway, and that's where I think our gradient came from. So basically, we probably just had, a medium, and everything was in this medium, and then more dense went down because it was more dense than the medium, less dense went up because it was less dense than the medium, and then that's how you ended up having a gradient and created a gradient, so to speak, because that is nature. More dense than the medium down, less dense than the medium up, and that's basically what the world is. So yeah, if there's a density gradient, then the less dense will move towards the less dense of that gradient. If there's a density gradient again, more dense will move towards the more dense of that gradient. If there's not a gradient, less dense will still rise, less dense in the medium will still rise, more dense in the medium will go down because it's more dense, and that's basically what nature is, and that's how we've got the gradient that we've got today, because less dense went up and more dense went down. So yeah, because it's trying to find equilibrium. So yeah, let's carry on. Objects will come to rest where their density matches that of the medium. If they can, then yes, they will.
We're expecting that there's a density gradient within the medium. Like in the air, the densest air is at the bottom, and the air up on top of the mountain is much less dense. So if you release a helium balloon, it will move up towards the less dense air, which is up, right? That is the core of the hypothesis. And to be very specific with it now, the direction of force is going to come from the direction of the density gradient within the medium, meaning
the direction of force comes from the relative density, the density differential between the object and the medium. That's where the force comes from. But obviously, you know, less dense down, more dense up than the medium. That's why we've got a gradient today, where we live. So yeah, less dense will always go up, more dense will always go down. If you change the layout, so that you have a gradient going in a different layout, then again, more dense will go towards more dense, less dense will go towards less dense, just as we've seen with the helium balloon in the car and on the Vomit Comet.
That it is dense air at the bottom, it is less dense up the mountain, and so the helium balloon is driven.
And I'd just like to add that's why the plumb bob and things went to the dense part, because more dense wants to go to more dense, less dense wants to go to less dense, everything's sequent equilibrium. So obviously, as I say, let's say everything started all in one medium, then the less dense would go up and the more dense would go down, because it's seeking its own density, and because it wants to go into equilibrium, and it can't go into equilibrium if everything's stuck in the middle of this medium. Everything's not going to be in equilibrium. So that's why more dense goes down and less dense go up, and that's how you end up with a pressure gradient. Again, this is my opinion, my thought process, my ideas. Yeah, let's go.
Towards the less dense, we could measure the density gradient within the medium, measure where the density is different within that single medium, and then the way the object moves will be along the direction of that gradient, which normally here on the ground is densest at the bottom and least dense up at the top. Okay, next point. The
next point, the density of the entire object is what counts. Yes, the density of the entire object, not what it's made of, not its individual materials. The overall density of the object is what matters.
Of the entire are often composite objects. For example, a helium balloon less dense than the medium of air and gradient of air contained within the submarine.
Running out of time, so I'm just going to skip bits to get through this as quickly as I can, as unfortunately I have other things to do, and I don't have much time. So the next one is the object must be in contact with the medium for this effect to occur. Yes, I've told people before that it needs to be immersed in the medium, it needs to have contact. I did actually describe it myself before as a contact force. So yes, it needs to have contact with the medium. The medium's differential and its differential between the object and the medium will give you the direction. Yes, it needs to be in contact for the effect to occur.
And so the medium that I'm not making suggesting that the density gradient is the cause of how objects move.
The density gradient is the cause. Not really, no. The relative density is the cause. Less dense moves to less dense, more dense moves to more dense, less dense than the medium up, more dense than the medium down, depending on how that gradient is obviously layered, whether it's layered more dense at the bottom and less dense at the top, or more dense to the side and less dense to the side. That will determine the direction of the object, whether it's I've lost my train of thought. Yeah, the gradient will give you the direction, because everything wants to seek equilibrium. So if there's no gradient, you will still have more dense down, less dense up. If there is a gradient, depending on how that gradient is layered, will depend how the object moves, because it wants to seek equilibrium. So less dense moves to less dense, more dense moves to more dense.
That when you release a balloon, it will move according to the way the density gradient is. The null hypothesis is what we call it if that's not true. It's the other way, and that would be that this density gradient we observe is not the cause of objects moving, but is in fact the result of something else. Perhaps
the density gradient is not the cause of objects moving. I'm not sure whether we can have a container with the same density all the way through, consistent density, but if we could, as I've said, more dense will always go up, I mean, more dense will always go down, less dense will always go up. You don't necessarily need a gradient for that to occur. The gradient will just determine where less dense is and where more dense is, and more dense moves to more dense, less dense moves to less dense, but the force and the cause is actually the density differential between the medium and the object.
The density gradient
The relative density
is the result of the same external influence that causes the helium balloon to move. So these are our two options. Either relative density says that the reason the helium balloon rises is because of the existence of a density gradient. And if that is not the case, we will be...
That's not necessarily the case. Again, it'll still rise even if there's not a density gradient, because more dense down, less dense up. You know, they want to see equilibrium, and they're not in equilibrium in the medium unless the medium's the same density as themselves.
Trying to show whether that is the case or the opposite, which is that even though the density gradient does not already exist, we can show that the helium balloon will move in a particular way. So if I have all of your points correct here, we'll start to design some experiments. We'll conduct those experiments and find out if your hypothesis holds up. Before I do, the main reason we're doing this, why we're going through this exercise of being extremely careful to get everything right, is before we do the experiments, I want to agree what those experiments mean. If we design an experiment based on this hypothesis and we invalidate the hypothesis, what does that mean? It's a really good exercise to try to fight your own internal biases, to decide before you do the experiment what your response should be to the null hypothesis.
Well, I agree with that. I think I think we need to decide what the experiment's going to be before we can come up with a hypothesis. So for me, depending on the experiment being conducted, if you could articulate an experiment to me, I could give you my hypothesis for what I think would or should happen, or, you know, like I could give you a hypothesis beforehand and we could do the experiment, and then there could be a factor in there, you know, a variable or something in there that changes the outcome kind of thing. So let's say, you know, something always happens and then we do an experiment and then we do this experiment in a way that like adds other forces or adds other components, other parts, other influences that can influence and change the effect or what we observe. And that, I wouldn't really say that's a fair test then of the hypothesis, because, you know, we need to control it so that there are no other forces or influences becoming a bigger factor than the relative density. If you know what I'm saying, because like obviously there are other things that you can do with certain things, and you can, you know, change the outcome of it based on what you add into this experiment kind of thing. So depending how we do the experiment would depend on the cause. And, you know, I could give you a hypothesis for what I think would happen, but I think it's better to know what experiment we're going to do to determine what hypothesis should happen. But if you don't want to do that, that's fine, and I can give you my hypothesis first. But there might be points when we come to do the experiments that I say, well, this could be a factor in what's changing the results kind of thing, what's changing the effects. And that might not be fair then, because those external factors, those influences may overtake the relative density, if that makes sense. You know, have a greater effect than the relative density, if that makes sense. But for me, my hypothesis would be, to put it basically, more dense than the medium down, less dense than the medium up. However, if we have a gradient in the medium, less dense than the medium will move towards the less dense, and more dense will move towards the more dense.
I don't think it's appropriate to completely throw out your hypothesis just based on a single experiment. Maybe we should do multiple experiments. How many experiments does it take before we declare that the hypothesis is definitely invalid and we need to rethink this whole situation?
I think once you do an experiment that completely destroys your idea of, you know, what it was, where you can literally say there's no other factors that's determining this should be just relative density, and then it doesn't work kind of thing, then obviously, you know, it's falsified then, isn't it? So that's how I'm thinking.
So looking forward to a response on those points, whether I've got your hypothesis correct on every point. And
so again, just to clarify, my hypothesis would be more dense than the medium down, less dense than the medium up. But if we have a gradient in that medium, then the less dense will move towards the less dense and the more dense will move towards the more dense. So yeah, the force is the relative density. but they want to seek equilibrium. So if there's a gradient, they will follow the gradient to seek their own density. So yeah.
What your responses should be if any experiment invalidates any point of that hypothesis. Okay?
If the experiments invalidate my hypothesis, and I'm happy that there's no other influence things that influenced it that changed the effects, that it has literally disproved relative density because, you know, it did for whatever reason. So long as there's not some other force which overtook and overpowered the relative density so that effect was greater than the relative density, then yes, I'm all for it. So yeah.
I'll talk to you soon. Thanks.
Okay, so great talking to you all. Take care and stay safe. Oh, actually, there was one more point that I wanted to bring up, which is just not necessarily for IconScienceSat, but for some people out there who think that falling and the vomit comet negates gravity. So I wrote a note saying, for all those who think dropping or falling or accelerating downwards somehow negates gravity or the downwards acceleration, also known as gravity, ask yourselves this. Gravity is meant to be mass attracting mass. When things are being dropped or falling, isn't that mass attracting mass, aka gravity to you guys? You know, things falling towards the mass of the Earth because of gravity, mass attracting mass. So again, how do you suppose or think or come to the conclusion that falling down is cancelling out gravity? Because that would show mass attracting mass, because they are mass. They are being attracted to the mass of the Earth. Therefore, in your eyes, that is showing mass attracting mass. So, you didn't take off gravity. All you're doing is focusing on a reference frame and saying, look, they're going up, but they're not actually going up, they're falling down. But that's a side note. Not for IconScienceSat, that's just for some of the other commenters. But yeah. So anyway, that's it. Thank you for listening. Take care and stay safe.